Namaskar. Today we discuss about the products of electrolysis. The product of the electrolysis is depends on nature of electrolyte and type of the electrodes. As we know, there are the two type of the electrodes. One is the active electrode, another one is known as inert electrodes. Inert electrodes like the platinum, gold and graphite does not participate in a chemical reaction. They just provide the surface for the electron exchange. Active electrodes do participate in chemical reaction used in electrolytic refining and in preparation of some chemical compounds. The product of electrolysis may be different for active and inert electrodes. Why? Because inert electrode just provides surface. On the other hand, active electrode participate in a chemical reaction. The product of electrolysis reaction depends on anion and cations standard electrode potential. Some electrochemical processes are kinetically very slow. At the lower voltage, the process don't seem to be occurred at all. In order to make these processes occur, some extra potential must be applied. This extra potential is known as over potential. So, some few reactions are influenced under over potential or extra potential. So let's discuss the product of the electrolysis with the help of few examples. Electrolysis of water. H2O is ionized like H plus and OH minus ion. We have two types of the electrodes in electrolytic cell, anode and cathode. Anode is a positive electrode and cathode is a negative electrode. So towards the anode, your OH minus ion attracted and the anode oxidation reaction is takes place. Due to the oxidation of OH minus ion, that is converted in O2 gas. At the cathode, your H plus ion attracted there. Due to the reduction, your H plus ion is converted in H2. So the net cell reaction that is the carried out in this one is like this. As we know, the number of the electrons should be the equal in anode and cathode reaction. To make the number of the electron equal in cathode and anode reaction, we multiply cathodic reaction by 2. Because in the cathodic reaction we have only the 2 electrons. By multiply this one, these 2 electrons convert into 4 electrons. 4 electron cancelled by these 4 electrons. So the net cell reaction that is carried out in this one is 4H plus ion react with 4 OH minus ion and convert into H2O plus H2 plus O2. 4H plus ion, from where these 4H plus ion is comes here. Now look there. Here is the 2H plus ion and we multiply this equation by 2. So 2 to the 4. So 4H plus ion. 4H plus ion and 4 OH minus ion combined and form the 4H2O. These 4H2O in LHS side and 2H2O in RHS side. So 2H2O of RHS side is cancelled by the 2H2O of LHS side. So in the LHS side we have only the 2H2O. So the net reaction is the 2H2O is converted in 2H2 plus O2. Again, electrolysis of the water with the new type of the reactions that is written in few books like this. H2O is ionized in H plus and in OH minus. At the anode, this reaction is carried out. 4 OH minus oxidized in H2O and oxygen. These 4 OH minus ions comes from the H2O. So we can write like this reaction. H2O is ionized in H plus and OH minus. In the equation we have 4 OH minus ions. So we should multiply this equation by 4. By addition of these two reactions, we obtain that your 4H2O, this OH minus 4OH minus is cancelled by this 4OH minus. So the remaining equation is that 4H2O is converting in 4H plus 2H2O plus O2 plus 4 electron. In RHS side, we have 2H2. In LHS side we have 4H2. So 2H2 cancelled by the 2H2. So remaining is the 2H2 is converting in 4H plus O2 plus 4 electron. This one is the net reaction on anode. In the same way, at the cathode, reaction that is carried out, 2H plus ion accept 2 electrons and convert in H2. The book say that the H plus ions comes from the H2O, so we should write this equation like this. Your 2H2O accept 2 electron and convert in H2 plus 2OH minus. So the net cell reaction that is carried out in this cell is reaction that is takes place on anode and the reaction that is takes place on cathode. Now on the anode reaction we have 4 electrons, but on the cathode reaction we have only the 2 electrons. So we follow a rule that the number of the electrons should be equal in anode reaction and cathode reaction. So we multiply anodic reaction by 1 and cathodic reaction by 2. By addition of this reaction we obtain this one is the net reaction. The net reaction is the 2H2O is converting in 2H2 plus O2. So students, it's up to you that how you write the electrolysis reaction of water, electrolysis of water reaction by the first method or by second method. Now we analyze some more electrolysis reactions. Now the electrolysis of molten sodium chloride. Molten sodium chloride mean liquid sodium chloride. Liquid sodium chloride that contain ions Na plus and Cl minus ions are present there. So at the anode Cl minus ion approaches there and Cl minus ion convert there in chlorine gas by losing 2 electrons or by oxidation. In the same way, at the cathode, Na plus ion approaches there and they reduced by 2 electrons and convert in solid sodium metal. NCR reaction, the NCR reaction is addition of anode plus cathode. So the net reaction is 2 Na plus and 2 Cl minus converted in Na solid and chlorine gas. So by molten electrolysis, molten sodium chloride electrolysis, we obtain pure sodium metal and chlorine gas. Now the electrolysis of the brine, aqueous solution of NaCl is known as the brine. NaCl is ionized like Na plus ion and Cl minus ion. On the other hand, H2 is ionized like H plus ion and OH minus ions. At the anode, now there is a competition between Cl minus ion and OH minus ion. Which one is first oxidized on anode? So this answer is exactly come from the electrochemical series. If you have the values, we can easily find out which one is first oxidized in the competition, Cl minus ion or OH minus ion. Listen, but now we not have electrochemical series. So we apply common sense here. Now there are the two species, Cl minus ion and OH minus ion is the species there. Among these, who can easily lose electron? Cl minus ion can easily lose electron compared to OH minus ion. Why? Because the oxygen electronegativity is higher than compared to Cl minus ion. So at the anode, Cl minus ion approaches the air and convert in chlorine gas. In the same way, at the cathode, again we have the competition between the Na plus ion and H plus ion. Who can easily accept the electron? As we know, the sodium is a metal. Metal's tendency to lose electrons instead of accepting electron. So at the cathode, H plus ion accept electron and convert in hydrogen gas. So NCR reaction, by the applying simple logic, we find out which one is oxidized at the anode and which one is reduced at the cathode. So NCR, when we write the NCR, according to the NCR, the reaction that is takes place at the anode and cathode, by addition of this one, we obtain that 2H plus ion react with 2 Cl minus ion and convert in hydrogen gas and chlorine gas. The remaining solution contain Na plus ion and OH minus ion that combines and form NaOH. So by the electrolysis of the brine, we obtain three products. Three products are, one is the NaOH, another one is the hydrogen gas, and another one is the chlorine gas. Now the electrolysis of the copper sulphate, aqueous copper sulphate solution. Copper sulphate is ionized like Cu plus 2 ion and sulphate ion, and H2 is ionized like H plus ion and OH minus ion. At the anode, again we apply our simple common sense. At the anode, which one is approaches at the anode, sulphate ion or OH minus ion? In the both, oxygen containing the electron. But in the case of the sulphate ion, that is extra stabilized due to some resonance. But in the case of OH minus ion, there is no resonance. So OH minus ion oxygen easily lose electron compared to the sulphate ion. So at the anode, this reaction takes place. At the cathode, now there is again competition between the Cu plus 2 ion and H plus ion. Which one species can easily accept electron? Your copper ion is easily accept electron compared to the hydrogen ion. So at the cathode, this reaction takes place. The net cell reaction takes place in the electrolysis of aqueous solution of copper sulphate is this one. At the cathode, the reaction takes place only the 2 electrons, but at the anode we have 4 electrons. So as a simple rule, the number of electrons should be same. So we multiply your cathodic reaction by 2. By addition of this one, we obtain this equation. There your 2 Cu plus 2 ions react with 4 OH minus ions and converted in copper, H2O and oxygen. Oxygen gas is released at anode, and the copper in the solid state that is depicted on cathode. Now the electrolysis of the copper sulphate with copper electrode. Copper electrodes, that is the active electrodes. So active electrode participate in a chemical reaction. So your anode, that is made by the impure copper. So at the anode, this reaction takes place. Your copper is converted into the copper plus ion by losing 2 electrons. These copper plus 2 ions come in the solution. At the same time, from the solution, your copper plus ion approaches at the cathode, that is made by the pure copper. The pure copper cathode attracts Cu plus 2 ions. Cu plus 2 ions, they are reduced and converted in copper. So the net cell reaction takes place. Your impure copper convert in copper ion, and your copper ion convert in copper pure. So the net reaction is that copper impure is converted in copper pure. This reaction or this method is used in the electro refining of copper with the help of the copper electrode. In this one, we have a impure copper anode and a wire-like cathode of pure copper. Now the aqueous solution of silver nitrate with silver electrodes. Silver electrodes are active electrodes. So at the anode, that is made by the pure silver. At the anode, this reaction takes place. Your silver is converted in Ag plus ion and comes in solution. At the cathode, that is made by the pure silver. At cathode, reduction of Ag plus ion takes place. Ag plus ions is converted in silver. So the net cell reaction takes place is your impure silver is converted in pure silver. Again, this reaction or this electrolytic method is used in electro refining of silver. Now the aqueous solution of silver nitrate with platinum electrode. Platinum electrodes are the inert electrodes. So the reaction takes place at the anode. At the anode, that is the competition between the OH minus ion and nitrate ion. In the both OH minus ion and nitrate ion, the negative charge is held by the oxygen, but nitrate ions, due to the resonance, those are stabilized. In case of the OH minus ion, those are not stabilized by the resonance. So your OH minus ion oxygen easily donate electrons. So in this race, OH minus ion win and approaches at the anode. At the anode, this reaction is takes place. On the other hand, at the cathode, again there is a race between the Ag plus ion and H plus ion. In this race, Ag plus ion win, because in reactivity series with Ag plus ion are above compared to H plus ion. So your Ag plus ion is converts in Ag. So the net reaction that is takes place in this one is your 4 Ag plus ion react with the 4 OH minus ion, convert in 4 Ag 2H2O and oxygen gas that is released at anode. Next example is a dilute solution of H2SO4 with platinum electrodes. Your H2SO4 is ionized H plus and sulfate ion, and your H2 is ionized H plus ion and OH minus ions. At the anode, the competition is between OH minus ion and sulfate ion. This competition is decided by who's the winner in this competition is decided by the concentration of the solution. If we have the dilute solution, on that time your OH minus ion win this race. If we have the concentrated solution, on that time your sulfate ion win this race, because in the concentrated ion, in the concentrated solutions, we have more number of the sulfate ions, but in the case of the dilute solution, we have the larger number of OH minus ions. So whenever such type of equations come there for the dilute solution, you should write for the OH minus ion. If you have the concentrated solution, you should write the reaction for sulfate ion. At the cathode, the reaction that is the takes place is your H plus ion convert in H2 gas. So the net reaction, we are writing this one for the dilute solution. So we use only the OH minus ion that is a oxidized on anode. So the net reaction is the 4H plus ion react with 4 OH minus ion and convert in 2H2O plus H2 plus O2, or your 2H2 that is present in RHS side and your 4H2O is present in LHS side. 2 cancel by the 2, the remaining is the 2H2O in RHS side. LHS side that is convert in H2 plus O2. An aqueous solution of copper chloride with platinum electrodes. Platinum electrodes are inert electrodes. They does not participate in a chemical reaction. At the anode, there is a competition between the Cl minus ion and OH minus ion. Your Cl minus ion lose electron and converts in chlorine gas. On the cathode, there is the competition between the Cu plus 2 ion and H plus ion. Cu2 plus ions are less electropositive compared to the H plus ion. So reduction of Cu plus 2 ions is takes place at a cathode. Your Cu2 plus ions are converted in copper. So the net cell reaction that is carried out in this equation is your copper ion react with the chloride ion and convert in copper and chlorine gas. Thank you for essentially listening us.